Okay, so here's the section 5.3, solving trig equations. This is part 1. So to solve a trig equation, we're basically solving for x or theta or whatever our variable is. And we're finding all the values where that variable makes the equation true, just like a normal equation. Now, in our case now, we have tangent of x is equal to 0. Well, I know tangent of x equals 0 occurs at when x is equal to 0 or at pi. Now that's only one rotation around our circle is when this occurs, but we would need to include any number of rotations around our circle. So we need to write a general equation representing all those solutions. So what we're going to do is we're going to draw a picture. And if I note where these solutions are, I have one at 0. And if I put the other one here of pi, you're going to notice that the distance between these is the same. And that's kind of a good thing, because then instead of having to write two equations to represent my solutions, I just have to write one if I can show that they're the same distance apart. And this is called wrapping it up. So, and it doesn't matter which one we use. We can either use the 0 or the pi, and we could say that x equals pi plus or minus, and this represents whether you're going clockwise or counterclockwise, and now we include the distance. Well, the distance between 0 and pi is just pi, and n to represent the number of revolutions. Okay, so that equation's done. So our solution is pi plus or minus pi n. Again, you could also have 0 plus or minus pi n. It means the same thing. On to the number 2. So our next equation is secant of x minus root 2 is equal to 0. So just like with solving all other equations, we want to get our variable by itself. So I'm going to move the root 2 to the other side. I'm going to get secant of x is equal to root 2. And now I just need to find where x is equal to root 2. Well, secant's a little harder for me to think of, so maybe I'm going to flip it over and make a cosine. Cosine of x would be 1 over root 2, which would mean I'm looking for root 2 over 2. So x is equal to so the cosine of x is equal to root 2 over 2 in two spots. The first one is right here at pi over 4, and the second one is over here, down here at 7 pi over 4. Now if I look at this, again I'm looking to see if I can wrap things up to make it a little easier. Well, the distance from here to here is 6 pi over 4. The distance from here to here is this is 1 pi, this is 1 over 4, that's another 1 over 4, so that's 2 pi over 4. Well, our two distances are not the same, so I'm not going to be able to wrap these ones up, or these two equations up, so I'm going to have to write both of them out. And so I get x equals pi over 4 plus or minus 2 pi n. And then my second equation is x equals 7 pi over 4 plus or minus 2 pi n. And these two solutions here are going to give me every place where secant of x minus root 2 is going to equal 0. Okay, let's move on to number 3. So this equation is 2 sine x cosine x equals root 3 sine x. So as with solving all equations, we want to get all our variables to one side, so I'm going to move the root 3 sine x to the other side. And that gives me 2 sine x cosine x minus the square root of 3 sine x equals 0. I noticed that I have a sine of x in both terms, so I'm going to factor out sine x. That leaves me with 2 cosine x minus the square root of 3 equals 0. And now I'm just going to do a little ZPP, or zero product property. I'm going to take the sine of x equals 0, and 2 cosine of x minus root 3 equals 0, and I'm going to solve both of these two equations now. Well, I know sine of x equals 0 occurs at 0 and pi, and if I solve for cosine here, I end up with cosine of x equals root 3 over 2, and I know that it occurs at pi over 6 and 11 pi over 6. Now if I put these on my graph to see where everything's at, and I'm going to use two different colors here. I'm going to use blue for the first one, and I'll use red for the second one. So just kind of so you can recognize, I'm going to use a blue highlight for this one, and a red for that one, or pink, I guess. So for blue, I am at 0 and pi. At pi over 6, I'm right here, and at 11 pi over 6, I'm down here. So if I look at these, you could put these on two separate graphs, but sometimes we're able to wrap between the two sets of solutions. So let's look at our points here. And if I notice that, well, the distance from here to here is 5 pi over 6, because I could rewrite this as 6 pi over 6. And the distance from here to here is 5 pi over 6. So those might work. But is it 5 pi over 6 to get back to here? It's got to be the same distance to get back to where you started. And that doesn't occur. I could use, so let me clean this up a little bit. So I'm going to take this away. I could use just the 0 and the pi. I could wrap those two together. And that's a common one you're going to find. You're going to find ones that are going to show up a pi distance apart. But I don't think we're going to be able to wrap up the other two. So we're going to end up with 3 things to write. So my final solutions are x equals 0 plus or minus pi n, comma, pi over 6 plus or minus 2 pi n, and then 11 pi over 6 plus or minus 2 pi n. And there's all our solutions for number 3. Let's move on to number 4. So there, our next equation is cosine squared x minus 1 is equal to 0. So if this was an equation such as x squared minus 1 equals 0, we would just move the 1 over and square root. We still do that. So we're going to just move the 1 over and take the square root of both sides. And that's going to leave me with cosine of x, if I take that square root, equals, now remember when you square root a variable, you have a positive and a negative. And so I get cosine of x is equal to plus or minus 1. Well, I know that cosine of x is positive 1 at 0, and it's negative 1 at pi, so on my graph, just like before, I have a solution at 0 and pi, and we've seen this one before. I can wrap these together into one equation, so x equals 0 plus or minus pi n. Okay, so that's number 4. Let's move on to number 5. So our equation is 2 sine squared x plus 1 equals 3 sine x. Okay, so same as always, move everything to one side. And I'm going to put this 3 sine x in the middle between the two. And that gives me 2 sine squared x minus 3 sine x plus 1 equals 0. This should look very familiar to you. This is like a quadratic equation that you've solved before of an x squared minus 3x plus 1. Or 2x squared minus 3x plus 1. Just factor it like you normally would. And this would factor be 2 sine x minus 1, and then sine x minus 1. And again, do the zero product property. 2 sine x minus 1 equals 0. So sine of x equals 1/2. Sine x minus 1 equals 0. So sine of x equals 1. Well, I know sine of x equals 1/2. That occurs at pi over 6. And 5 pi over 6. Sine of x equals 1 occurs at pi over 2. Okay, so let's put these on our graph. And see how they look. Pi over 6 is right about here. 5 pi over 6 is over here. And 1 is straight up at pi over 2. Okay. And just looking at this, I can see that they're not going to be the same distance apart. So I'm going to need to write 3 equations. So let's just write them. So my first equation is pi over 6 plus or minus 2 pi n, comma, 5 pi over 6 plus or minus 2 pi n, and pi over 2 plus or minus 2 pi n. Okay, and that is number 5. Let's move on to number 6. So we have the equation 4 cosine squared x minus 3 equals 0. Okay, so we've seen something like this before, so I'd like you to pause your video and solve for x and see if we match. And you should have ended up with the cosine of x is equal to plus or minus root 3 over 2. I know that occurs at x equals pi over 6 and 11 pi over 6 for the positive root 3 over 2. And for the negative, it would be 5 pi over 6 and 7 pi over 6. So let's put all these on the same graph and see what we notice. So the pi over 6, I'm going to put here, and its other positive one was down here at 11 pi over 6. Then I have 5 pi over 6 here, and 7 pi over 6. Okay. Alright, so I'd like you to pause your video, and I want you to try to write the equations for your solutions here. Okay, so the solutions were pi over 6 plus or minus pi n, and 5 pi over 6 plus or minus pi n. You should have noticed that this pi over 6 and this 7 pi over 6 are pi apart. So if I added 6 over 6, I would end up at the 7 pi over 6. As well as the 5 pi over 6 and the 11 pi over 6, they're also a distance of pi apart. So instead of having to write 4 equations, we only would need to write 2. Okay, so that's the notes for this section. If you have any questions, make sure you come to class with them.